so I think that finishes up what you need to do in section 12.4. Okay, cool. Yep, okay, Alan. Oh, here's how they say it. Use properties of logs to write the expression as a single logarithm. That's putting them together. How did it say it the other way? Wait, let me see. Oh, okay. Use properties of logs to write the expression in terms of logarithms of, break it back up. Ash?
It was for the ln. We can't do anything when there's a sign between the letters.
Yeah, what I'm trying to make clear here is ln of a over b is ln of a minus ln of b all day long. That's the property. ln of a minus b has no property. Ain't shit you can do with it. Think about it. What would I do first here? Inside here, right?
Yeah.
And if I divide a and b, what would I do with their powers since they have the same base? I was subtracting. So that's really all that's saying. Is what I would do here is divide them. If I knew what the base was, it's the same. If I knew what the powers were, I could subtract them. Well, that's what that's saying. Here, what do I do when I subtract the same base? I don't know. Again, x to the fourth minus x to the third is that. That's all you can do with it. But x to the fourth divided by x cubed, can you do something with that?
Yeah.
That's why this can be done and this can't. That's exactly why. And it's real easy for our brain to go, I know what to do with minus, and then it just hijacks us, and I get this kind of thing. I almost don't want to write that. No, immediately, no. Hell no. Okay. All right. The more you realize logs are powers, the more sense this kind of thing makes. Okay. Yes, okay. I think I got everything. Yes, cool. All right, so now we're going to get into solving equations. We already solved a few equations with logarithms in them, right? So let's keep going with logs for a minute. And then we'll come back and we have to solve equations that have exponential stuff in them. Yummy. Okay. So for example, what if I had log base 3 of x minus log base 3 of x plus 2 equals 1. Sure. Let's see if this has an answer. So what do I need to do first? Yeah, if this stupid thing wasn't there, what could I do immediately? What can I do with this immediately? 3 to the first power equals x plus 2, right? I get rid of the logarithm by rewriting it. That stupid thing is in my way, so what can I do between these two? This would be log base 3 of. So that's why we learn the properties of logarithms, because I need them to be able to solve equations, which is really the bread and butter of algebra. Which is why algebra is kind of like the basic skill you need for any sciences and so forth, because I have to be able to solve any, and this happens all the damn time in science, logarithms, every damn where. So I got to be able to solve equations, and what do I have to know to solve equations? I have to know the properties.
What is logarithm negative?
So again, so remember we had this here earlier, and what was that? Using the property? ln of 11?
Yeah. Oh, and the
Minus. So if I go this way, where'd the minus go? It didn't go anywhere. It's just I would subtract these. That's what that side says. Do you see? So I'm able to go the other way. So the minus didn't really go anywhere. It's just that whatever the power is on this and this, I would subtract them. So that's why these are the same thing. They represent the same thing. But now what can I do? It doesn't matter how much shit's in there. It's log base 3 is something is 1. So I can rewrite that as 3 to the first equals, yeah, whatever the hell's in there. Could be some big giant thing. Who cares? Don't matter. Now, How do you solve that?
Yeah.
Multiply both sides.
Beautiful. What's the worst part of this equation? The x plus 2 is down there. All right, so immediately make that not true anymore. Multiply by x plus 2. So the minute the logarithm goes away, you're back a few chapters. Don't think it's some new thing. No, the log's gone. Now it's old shit. Right? So here they cancel. Here I get what?
3x plus x.
X negative 3.
And subtract x. Subtract 3x.
Okay, subtract 3x. All right, now, logarithms and radicals are similar in a lot of ways. And here's one big place they're similar. You have to check the answer. And who remembers what a log looks like? So here's an exponential, right? There's the exponential. There's like 3 to the x. Is that cool? That would be like 3 to the x. What does a log look like then? It has to be a reflection, so what would it look like? Can you do it in the air? There's somebody's doing it in the air for me. I like it. So it's got to be like this. What does that say about the domain? This log base 3 of x. What's the domain of it? What's the lowest it can go? It can't even quite get there. Can it use negative x's?
No.
Because it doesn't exist over there. In fact, what's happening here? Can you use 0?
No.
No.
It never gets there. So the domain would be 0 to infinity. So what's wrong with the... Is there a problem with the answer I got? If it makes any of the insides 0 or less, it's no good. Well, if x is negative 3, then...
It's wrong.
Yeah, it's no good. It's sort of like having square root of x. If I got x equal negative 3, that would be no good because I want to stay real, right? Here, I don't know. Based on what I just said, some of you guys might be like, oh, how do complex numbers work with logs? We're not going to talk about that here. Some of you guys are like, thank you. Right? We won't do that. It's all going to be real shit, but there is a connection. But here, so what's the answer? No solution. Why? Because it freaks a log out. Does it freak this log out too?
Yeah.
Yeah, it does, man. It's just freaky. All right.
So if it's never touched the 0, why would go 0 into infinity?
Does this include 0?
Yes, 0.
No. If I wanted to include 0, what would be here?
Oh,
A bracket. Yeah. But I need to include 0.00000000001, right? That's fine. All right, Jeff, don't be a dork. I have to include every damn thing except exactly 0. So that's the best way we can come up with. It's every number except exactly 0. So it's the number that's right next to 0. And when I say that, it sounds like it makes sense, but that makes no sense. What number is right next to 1? You can't tell me. It's 1.0 forever, and then a 1 at the end of the infinite universe. No, there's no. It's free. All right, sorry. Well, sidetrack.
How did you check it?
Let's focus on that specifically. Let me build up to your question. How would I figure out this guy's domain?
Make it greater than 0.
Yeah, the inside
Greater or equal
has to be greater than or equal to 0. And then you would solve. So how would I figure out the domain of this thing? It's almost the same, except now the inside has to be only greater than 0 because a log can't even handle 0. So what's the domain of this one?
Greater than 0.
Yeah, x has to be greater than 0. So we're off the bat, we're screwed. X, the only answer I got was negative, so I'm screwed. Now be really careful. All right, so everybody decent with that? Logarithms are very much like radicals in a few different ways. They're not the same damn thing. So when you're doing an equation with them, though, you got to check your answer. Make sure it doesn't freak anybody out. I can't exist back here for logarithm, so if I get negative 3, it's going to freak the hell out. All right, now, if my equation had started off with like this in it, and this maybe, sure, why not? Blah, blah, blah. If those were in my equation and I got x equal negative 3, is there no solution for that one?
You're cool. No. Well, there is a solution.
There is this, negative 3 is fine. Why is negative 3 fine? What's the inside of x is negative 3?
Bigger than
4. What's the inside of 2? Thanks for playing. But at least it's bigger than 0. It didn't make anybody less than 0. So don't just look at the answer and say, oh, it's negative, screw it. No, it's fine. That can go all the way down to almost negative 7. That can go down almost negative 5. So negative 3 is fine. Cool, I like it.
What about the range?
Oh, okay. The range is kind of nice. How far down does this go?
almost 0.
So what's the range, and then how far up does this go? So the range is... In fact, here's something I told somebody earlier today. It was in my office. What's the, for this guy, what's the domain of this guy? Are there any x's I can't use? No, so the domain is negative infinity to infinity, right? What's the range? What's the smallest output? Almost
Almost 0.
0. All right, now watch this. Kind of cool. How are this and this related? Inverse functions. And what do they do with each other's x and y? Switch them. What's domain? Domain is all about the x's. Range is all about the y's. Look what happened to the domain and range. Oh shit. I mean, so everything having to do with x gets flipped, and everything having to do with y gets flipped between inverse functions. It's beautiful. So if I know the domain and range of a function, I switch them, and that's the domain and range of the inverse function. Why? Because that's what inverse functions do. They switch x and y. That's really nice. Let that be really, really freaking nice. If you go into pre-calculus and go do some trig, that's going to become huge. Huge. I can't do Donald Trump. I'm kind of happy about that, actually. Thank you. All right. I have to sit on my political views. I don't want anybody to be uncomfortable. It's not easy for me. Okay. Let's see. Oh, all right. So if there would have been a plus here, what would have happened?
You wrote it as multiplication.
I would have wrote it as x times x plus 2. So let's try one out. This is a little bit trickier to make it work right. So let me grab one from the book. Not you. None of you. What the hell? Give me a good one. Here we go. All right. Do every one of those? There we go. Okay.
Log base 2 of x minus 1.
Plus log base 2 of x plus 1 equals 3. Yeah, cool. Just have a nice answer. So how can I rewrite this immediately? Log base 2 of...
X minus 1 squared.
I like it. Some of you guys are like, let me just do that. Well, what do you get when you multiply those?
X squared plus...
Yeah, minus x plus x, right? It's the difference of squares pair, right? They're like conjugates of each other. Oh, shit. So minus 1.
To the third power.
Yeah, so now I've got a single logarithm. So I can write it as 2
The third.
to the third is x squared minus 1. Let me stop for a second. And what is 2 cubed? 8. And I can add 1, right? So I get 9 is x squared. X is?
3.
No.
No, positive, negative.
Good. Plus or minus 3. Now, so you got to show me both answers. Do both answers work? Well, if I plug a 3 in there, I get 4 and 2, so that's good, right? If I plug a negative 3 in there, I get, oh shit. So the only answer is positive 3. If you only write positive 3, I'm worried that you didn't realize that negative 3 was an option.
When you put the YouTube,
I always put it, it's up there by that evening of the same day. Yes. Depending on internet connection. Yeah. Okay. All right. So that's logarithmic equations, right? When there's one log to begin with, oh, thank God. If there's more than one log, combine them. So what about exponential? Well, let's start with an easy one. Or actually, let's do this. Another thing that's perfectly fine to do is to say, hey, Jeff, man, can we take a break? Do you guys want a break right now before we get into this? Okay, good. So do I. So come back 5 after.